Hi everyone, welcome to Bodhi Coding. In the previous video, we had created the model and trained the model for each type of algorithms like logistic regression, random forest classifiers and resistance classifiers. Now we can discuss about how all these things we can get it. So we have created the list which contain of the dictionaries like model name and corresponding class of that model particular algorithm. Okay, so how it is working means it was firstly coming into that. So first of all we will take this one alone. So for every dictionary here it will be running the program, and it will be one dictionary will be coming one by one here. So let we take one dictionary here. So for the logistic regression, first of all it will print the name, and this logistic regression class will be assigned to this model. Okay, then model once initiated, we will feed this training data. Okay, training data into the model. Once the model learn, we will predict the values, the predicted value for the same training data, and we will get the accuracy score. So this will calculate at the accuracy score means it will compare the both X train and train predicted. Here the predicted value, right? Likewise it will compare, it will make that how many it is correct. So like if it is for an example we have 100 record means the correct value is like 80 values matching both side means the score will be the 80. Okay, out of 100. So that is the accuracy score purpose. Likewise we have predicted the testing data also, that is it is here printed. Okay, so this is the training accuracy and testing accuracy. Why here we had calculated the training accuracy? So if it is the training accuracy is more, if it is like 99% or 100% or anything kind of, okay, the full the more value, and it is having the very less testing accuracy means the model is actually maybe it was imbalanced data set, or it may be the overfitting means it can be training. In the training it can be learn the pattern, but it could not predict the testing purpose. Okay, when it has come the new value, it could not predict that. So we can say that is the overfitting, or else we can check whether the target variable is imbalanced. Imbalanced data means let me explain that. If we have 100 record means most of the record will be particularly belongs to that particular classes. 99 of the record is belongs to the one, and only 10 means it will not predict the values for the 0. So that is the imbalanced data set. Okay, we have to analyze that, we have to address that problem. Okay, that is the problem here. That is why we are calculate the training and test accuracy to ensure that model is overfitting, or else it is that the data having the imbalanced data set. Okay, the next is we are having it in the confusion matrix. What is this confusion matrix means? Let me take this side is 0 and 1 will be the actual the predicted values, and the above value 0 and 1 will be the actual values. Okay, so in the test set, okay, in the y test will be the 0 and 1 here, it will be the actual values. Okay, we have splitted the data set, correct? The test is actually it was predicted. Okay, it is predicted from the model. So how many of this? Okay, let me we can see that 3000 here around the 3000 value. Okay, it is really predicted correctly whether that employee is retention or not, whether that employee leave the company or not. So the actual value is 0, that employee is leave the company, and also our model itself predicted it as the 0, so he is leave the company. Okay, here the true value, this will be, we can say that this is the true negative. Actually it was negative, and also it was negative. Sorry, the employee is not relieved the company here. The 0 means not relieved. Sorry. Okay, and so here the employee is actually not relieved, and also it is predicted as the not relieved. Okay, it is a true negative. It is correctly find that thing is not happened here. That event is not happened here. Okay. Likewise, we have in the actual value we have it here like 3700. Okay, this will be 32,000. Okay, 3700. Okay, 3700 values. We have actual values as 1. The employee is actually leave the company, and our model itself also predicted that he leaves the company. Okay, so like this will be called as a true positive. Okay, this will be the true negative around 32 here yes, here around 3200 record, here around 3070, sorry, 3070 record. Okay, let me make it to 3.7 into the okay, the 100. Okay, so actually it will be the actual value. The concept is here is this is the actual value, this is the predicted values. Okay, and what does this means? Actually that employee is not relieve the company, but our model is actually predicted it was he is relieve the company. Okay, this will be the false value around 700 values. Okay, this will be the false value. He is not leave the company, but our model predicted us he will leave the company. Okay, so this is the wrong value, right? So we can mention it as the false positive. This is the false positive. Okay, likewise this will be the actually that employees leave the company, but our model predicted us he is not leave the company. Okay, so in the real world model prediction we have to analyze the cost of this wrong predictions. Okay, whether that wrong prediction cost is more means we have to rethink to any kind of model adjusting. We have to do that model hyperparameter, this kind of things we have to do that. Okay, somehow we are missing that some values in the model building. We have to correct it based on the cost of this wrong prediction. Okay, so actually confusion matrix is this one, and so how many it was actually predicted as employee leave, and how many actually it was predicted as employee leave. Likewise, how many he is not leave the company, and how many predicted he is leave the company. Okay, so we are comparing the actual value and prediction value here. So if we clearly say that this testing accuracy is based on this one alone. Okay, okay, so this, what is this classification report? Okay, once we got the testing accuracy and training accuracy, but what happened means so in the testing accuracy it will be around 90%, but is it biased for the particular value? So let me see that. So for that 0, it is we are having only 2 value. Like, so let me take a sample of 100 records. Okay, in that 100 records we have a 81 value and 20 value. Okay, but in the predicted 80 value will be predicted as 1 correctly, but only 10 will be predicted as 0. Okay, in that purpose we have a 90% accuracy, but for the particular 0, okay, particular event we don't have a much much prediction. Okay, only the 50%. Okay, so we can also take it here as the example. Okay, for the not leave the company, the employee not leave the company, it will predict the 82%, but the leave the company will be 58. Okay, in that case we have to reconsider the model evaluation. Okay, model building. Okay, what is this precision? What does this precision means? Actually the total positive we have having, right? So we have to actually the accuracy of positive prediction. Okay, accuracy of positive prediction. Okay, so how much it is predicted? So we have a true positive and a false positive here, right? So this is the false positive and the true positive. So how much of it is, how much it is correct? So that is the precision here. That is the precision rate, the false positive rate. Okay, and likewise, what is this recall? The recall means how much of prediction is correct, false, true is correct in the real positive. Okay, real positive. Okay, so here we are having the predicted is 0, okay, but it is actually 1. Okay, this will be the total positive, but out of it, it is how much it is the correct positive. Okay, that is the recall here. And the F1 score is nothing but it will be the percentage of the positive prediction. Okay, we have a separate formula for that. And okay, if you see that comparing these three models, these three algorithms, if we clearly see that in the decision tree or the, okay, so here having the logistic regression 17% accuracy only. Okay, here the random forest we have a 98% in the test accuracy itself. Comparing with this one is high. Okay, and also for the decision tree classifier also we have a good accuracy. Okay, now these two, this random forest classifier and also the decision tree having the equal nearly equal accuracy. And while comparing while coming to the classification report, it will having the highest precision for both the class, for the living and the not living, it will having the highest precision value. So we can decide that we can go with the random forest classifier further for the deployment. Okay, so actually we had completed that data science full sample simple project. Okay, this is an example for that. You can also try this same method with other some data set you are having, and you can practice more on this. Okay, and also you can make some trying some model data modification based on this testing and training accuracy and recall values. Okay, and you can get it you can get the more values, try to more values according to the business logic or something else. Okay, yeah, thanks everyone.